Okay, cool. Thanks a lot, guys. My name is Christian, and today we are speaking about IoT on AWS. And some facts to my person. I'm a solution architect for the enterprise segment in manufacturing markets, and I'm supporting enterprise customers. I'm living in Upper Austria and Schering, so it's across the border on the Austrian side. So if anybody wants to speak a mix of Lower Bavarian or Innviertler slang, come to me afterwards. And yes, I'm working about 23 years in the IoT area, and I like to implement architecture, infrastructure, mainly based on enterprise customers. And as I joined AWS almost 2 years ago, I like it because the innovation, the pace of innovation AWS is driving, and that's really cool. If you want to get connected with me, you can make a picture of the QR code or get onto LinkedIn and connect to me. You can always reach me out by email address if you have follow questions which I cannot answer today. But let's dive into some IoT stuff. And lots of customers often have a simple question. So how can I gather the state of IoT devices? And can I get reason on that data? And what problem do I want to serve or solve with that IoT data I have? And we have a lot of customers doing that, and our mission as AWS is that we can give you the state to each thing, and we can give you the capability to do reasoning, to some processing analytics on the IoT data, and we give you all the capabilities to solve your business problems. And some of the customers we have, it's only a bunch of them, but I want to pick one out. This is Deutsche Bahn, DB, and Deutsche Bahn was very successful using the AWS IoT framework for managing their wagons, where the wagons are on the trail, managing, coordinating them, and also analyze their movements to optimize their schedule. But nobody wants to buy an IoT technology because you want to get some data out of it. And IoT's things, maybe some sensors, very thumb sensor, only sending, for example, temperature. So what's temperature? It's not really a business outcome. And you're seeking for business outcomes, and we try to help you. And a lot of customers doing different things with IoT stuff. Because I'm coming from the enterprise segment, so the left upper enterprise customers have factories, they have shop floors, machineries are running there, and they are collecting a lot of data. But to improve their overall equipment efficiency, that means the quality of the products they are building on their product lines, or maybe using some power grids. It's very important to avoid a blackout, to organize the stream of current and voltage through a power grid. So there you have a lot of sensors there. And of course, autonomous driving or connected vehicle. So lots of car vendors already connected their cars for SOS signal, but also for improving their navigation maps or for do some streaming services within the car. So lots of things are happening, or agriculture to track the tractor when he is harvesting on the field outside. So lots of business cases outside there, but let's dive a bit deeper what we as AWS can do for you. And let's speak about the baseline and the fundamental we are offering to you. And we are talking about the virtuous cycle, because we think you have to think about 3 different areas when you want to build a scalable, high available, secure IoT environment, and which is very important. And I'd like to start with the very important thing, that's the IoT things. The things itself, that's things running at the edge, running on the shop floor, running in your mobile device, running in your car. How to provision them, how to connect them, or locally communicate. For example, if you're sitting in a car, you have more than one sensor in there. So how do they communicate to each other within the car without, when he comes back to the garage, he has some Wi-Fi there, and the tractor can send up the snapshot of the harvesting data to the cloud, and then you can start up the analytics. Very important is security, mutual authentication. So both must know and must have their certificates to check the authentication. Local resource access is important, especially when you have some devices like here. If you want to access some local storage, want to access to some special hardware which is within your Greengrass gateway. For example, a GPU or some other multiplexer which are necessary for devices. You need local access. Greengrass is handling that. And how does it look like within? That's a logical view of a Greengrass component. So you have several lambdas running on it. And lambda can do anything what you are programming. We will see some lambda sample code if you're interested, and I will show how it works with an IoT button, for example. And all your containers you can run on your Greengrass hardware. It depends on the resources your Greengrass gateway have, so how many Dockers you can run there. But the meaning of that is that you should run all the latency sensitive parts on the Greengrass, at the shop floor, at the factory, at your mobile device, at your car, and only send that data which is necessary to the cloud. Then you have the IoT Greengrass, it's the software part and the runtime engine. And Greengrass uses under the hood runC. I'm not sure if anybody knows runC. It's a really lightweight universal container runtime, and it can start Docker images. And then you have a Linux operating system and some x86 or ARM-based hardware. So for that, I want to give you some short view how Greengrass looks like in our AWS queue. So give me some seconds. So now you should see my screen in some few seconds. Okay. Is it fine for you in the back? Should I make it a bit larger? A bit larger. Okay. So that's the, when you jump into the AWS GUI, you have an AWS IoT section, and I'm jumping directly to the Greengrass sections. And within the Greengrass sections, we have Greengrass groups, we have Greengrass cores, and we have devices. A Greengrass core is one of that device where the core software is running. That's the runtime of Greengrass. And it's running on any hardware which is certified. And in our case, it's the DeepLens. The DeepLens is the same thing. It's the gateway, it's the Greengrass core is running on it. And let's have a look what is defining on it. So it's only a thing which is running on any AWS account. That's it. And it has a certification which is needed for the mutual secure communication between the IoT core. On the other hand, the group combines all devices which have the same attributes, the same properties. So let's group some things together and roll up some Lambda functions on all the groups. So if we have maybe 10 of that cameras, we have 10 cameras within one group. And what does this mean? I can push some Lambda functions on it, and we will come later to that, but I have one Lambda function which is called face detection. So one Lambda is running and you can deploy it on the whole group. But not only that, you can also define some resources, as I already mentioned, to access local resources. For example, the GPU resource. That's built in on the small main board, but to give the Lambda function access to the GPU resources to do very fast calculation inference, you can detect and use that images. If you want to install some additional Dockers I already mentioned, where your image, your custom image is, then you can add a connector and push on some Docker applications on the Greengrass. So that's how we're handling Greengrass. It's one gateway. There is one core which is doing the runtime, and you can connect up to 200 devices, IoT things, onto that. If that's not enough, you can run an additional core with another group with 200 additional devices. And if you maybe have 10,000 devices in one factory shop, then we have another solution, and it's called Sitewise, and we will come to them a bit later. That's for short how Greengrass is connected and used here. So, but as I already mentioned, if you are a device maker, so you are designing chips, designing small microcontrollers or microprocessors, how can you be sure that that's working with AWS services? And for that, we have a service which is called Device Tester. Device Tester is a framework which tests your hardware running FreeRTOS on it or running AWS IoT Greengrass on it. And you get a report and how your hardware is running and all that stuff. If the hardware is okay, then you can go further steps and let's certify your hardware, and then you are listed in our certified hardware vendors. That's for the edge part. Let's jump into the main component of IoT. It's the core, the IoT core, which is doing the brokering and the messaging, handling all the IoT data coming in. Also how to do the fleet management. So if you have thousands of devices, how to manage them. And also what is the device defender. Because security is job zero at AWS, we have a lot of security features and we're enhancing them step by step, and every time we see any leaks, we will see that it is fixed and we give the best opportunity, capabilities, and breadth for security. So how can we handle that my data coming from IoT is secure, and how can you generate all the IT endpoints securely? The IoT core, you can imagine that's an endpoint outside on the internet, and it's a high available and scalable endpoint. All your IT devices can connect. They can connect via MQTT directly, or if you have a Greengrass gateway between, then the Greengrass gateway can connect to it. Or if you have an SDK, IoT SDK from AWS, then you have applications which can directly communicate with the IoT core. The second thing is the core cares about routing all the messages coming in, acting on messaging. For example, battery is sending one message attribute, battery is low on current, then you can act on that and can mitigate and send some notifications to the operations manager outside there. Shadow devices I've already mentioned, and of course IoT Core integrates very tightly into a bunch of IoT services, which makes sense to use them for analytics or storing data on purpose-built databases or using some other artificial intelligence services we have, for example, image recognition. But what are the most important parts the IoT Core consists of? It's the identity service. That means if an IoT device comes, it must authorize there and authenticate, so that is the device that I expect, so is the certificate correct, and what permissions the IoT device have in the IoT core. For example, you have an IoT device which can publish some sensor data to a dedicated topic, but not to another topic, or it is only allowed to read some data from MQTT. The device gateway is under the hood of the IoT core, which delivers you the connectivity part. So to give you some numbers, you can, for example, connect 500,000 connects from new devices, or devices can be connected concurrently to the IoT core, but the 500,000 devices which are connected can be adjusted calling our AWS support, or you can have more than 2,000 new connection requests from IoT devices per second. The message broker is a reliable and fast transport, and it's the wheel between. So it's sending the data, it can push data to another topics, or it can push data, for example, to DynamoDB, or can push data to S3, or to only a Lambda where your code is running. The registry, the last point, it's important to register all the devices so that you can search your catalog, which devices you have, that you can map the devices to rules, and if you're using Greengrass, to map them to groups so that you can combine them together. And we will see another things, it's called Sitewise Monitor, so that you can see real-time dashboard, which IoT sensor delivers which data, and for that you need the device in the system itself. So it's like the system record. Identity services, and I will go a bit deeper into IoT Core because it's very important, is responsible to do all the security parts. So X509, it's the default certificate standard which is used for mutual certificate exchange. We also use for HTTP requests the signature 4.4. So every API call which runs against the AWS API needs a signed HTTP request. And normally you need a temporary access key and secret key. And with them together you can sign your HTTP request so that it's secure. But you can also write custom authorizer based on Lambda. So if you have an application, it's not an IoT device, you can also use Lambda on that to authenticate. The device feature is the endpoint, the high available endpoint. It's a regional endpoint, so you have to decide if you use the endpoint for region Frankfurt, for example, or for region US West in US. The message broker itself, it's called MQTT, which is in the backend, and I'm not sure if anybody knows why it is called MQTT. Anybody knows? MQ comes from IBM. IBM had an application called MQ Series, and MQ Series was, and one kind of MQ Series was a protocol or a solution which allows to publish and subscribe to a queue. But it's not the queue like polling data, but you can subscribe, so you have multiple subscribers to one data stream. And that's coming from IBM, and TT stands for telemetry transportation. That's the name for MQTT. The rules engine itself is built in. So if you get some data, and we will see it when we're going through the small IoT button demo, how we can act on some actions happens in their IoT data. You can use a SQL similar kind of language to filter out all the attributes you like and react on that data and process them further, for example, in any of the Lambda functions. Device Shadow helps you to automatically synchronize from the offline state into the shadow device if the device gets online, and it's very often necessary because not every device think about autonomous driving cars. We don't really have LTE 5 everywhere or LTE 4, but if you have some black areas, then also the car should work further on and not stop. And that's the reason we need some shadow device, so that applications where the operators are dealing and controlling the devices and also the device itself can communicate in a safe manner together. And the registry itself, so that means you can define some things, types, you can group things together in thing groups. So it's more an organizational thing that you as human can see what happens within your UI. And last but least, it's the Alexa voice integration. It's also a new thing which was announced at reInvent this 2019, and that helps IoT vendors that really small devices are capable to react on Alexa built-in features. So you can have a really microcontroller unit-based light switch, but you don't have a lot of resources for memory or for natural language processing and doing some utterance detection and what is the intent of that, and then send the message to the right light. With that integration, the sensor only sends maybe the text which was detected from the user, and the text is sent via IoT Core MQTT message further on to the Alexa, which is doing all the intent recognition and send them back via IoT Core to the device. So that's fully integrated, and you're also aware that if you're using your companion app on your mobile device, you can also control your light switch because you can only also connect your application, your apps on the devices to Alexa service. For that, I will jump for short in UI and show you how the IoT Core looks like in the GUI. Here. We have things, so that means you have devices, and a thing contains a lot of different things. It contains what is the name, so that you can see how to address the thing within the UI. In this case, we have the deep lens, which is also an IoT thing. It's indeed, yes, it's also a Greengrass core device, but it's also a thing. And you have some security, and it's very important. That's a certificate, and you can send the request which it's generated and send the certificate NDCA, the root CA, back to the device again. And also define the policies, what the deep lens is allowed to do. And if you are already aware what policies are in AWS, all the policy documents are designed in JSON similar kind. And in this way, this device is able to use all the services from IoT in Greengrass, and it doesn't matter which deep lens camera it is. So that's very important for that. And to see what IoT devices are sending, so they are sending all the IoT data which is coming from the device. And let's see how it looks like. So we'll just switch back. What we can see here is an IoT button. And the IoT button is only a very simple device. It has 3 functions. You can click single, you have a double click, and you have a long click on it. That's it. And to see if that is working, you can do a test on it and see if the device is sending anything. For that, you can subscribe to that IoT button. I will use the wildcard, which is a hashtag. And if I click on the button, it takes some seconds, and you see that I clicked single. Hopefully you can see it. If I click double on it, then you will see hopefully that we send it a double click here. So that's the IoT core. You get the full message in JSON format, and you can do with that what you want. And we come back what the rules are, and that's the filter how you get on the data. So it's like in a SQL language, and you can, in this case, we are grabbing all the data we have. And the Lambda function is getting the whole output of all 3 attributes, and the Lambda function can act on it. And we come back a little bit later in a couple of minutes of that. That's about the IoT core. So, but what happens if you have not only one IoT button, but Amazon maybe has sold 1 million of them, and you want to use them all at MSG, and every employee gets one of that. So you have to do a fleet management of all the buttons. And the fleet management takes care about how to register all the buttons, so you can push some kind of JSON document and do a bulk registration of all your IoT devices. You can do a real-time search and indexing all the devices so that all device gets names. All devices gets monitored. Our service is called CloudWatch logs, so you can send all the logs which are created from a device into CloudWatch for historical analysis. And for certain IoT devices, it depends on which, it's possible that you can open and secure tunnel to that device itself. What does this mean in general? If you have a device, normally, imagine that you have a machine outside on the shop floor, and you need the screen of the machine because it's based on Windows. And it's very often that you have Windows 95 or 98 on some machines outside there. You're installing in VNC, so a remote service that you can put the image from that. But you have to maintain them, you have to patch them, you need a virus scanner, what else? But what's happened if you can trigger them from the outside, and we're using or calling them secure tunnel? That means that on the device, for example on a Greengrass device, you can install a local proxy program, and that gets triggered by an MQTT push. So MQTT push gets sent from the cloud to the device, then the device starts up the proxy and makes a backwards tunnel up, and you can redirect your SSH session to the device itself. So it makes it very simple to do that. It's very important that it's a very limited number of admins, for example, or whatever, that is very strict policies on that. I already mentioned it, but it's very important that an IoT device is not a member of a DDoS bot network, right? So how to avoid that? And we have a tool that's called Device Defender. And the main task of the device defender is to continuously audit the device. What does this mean? Has the IoT device changed their certificate? Has they changed their IP address? Have they changed their name? Or have they opened some additional ports we are not expecting? Normally we are communicating via 8883, that's the default MQTT port. But what's happened if the port 22 is open? Maybe it shouldn't be. And Defender is detecting that and sending them to a defined MQTT topic within your IoT core, which is a regional service, and you can act on that. Additional, it detects, because before you define a Defender baseline or a policy, you can define the baseline, what you are expecting. If you're expecting only that special port and it is drifting so that you have additional ports, what should I do? Should I send an alarm to anybody? Or we like automatism, so automate everything what you can, like to mitigate it automatically. So why we should send them an email to the administrator or shop floor manager? Let's do and block the port automatically. That can be done via Device Defender. And the Device Defender is supported when you're running the SDK on it or when you're running Greengrass. So due to the time, so I have 45 minutes used, and I'm still on a half. Way too close today, but hopefully you have some more minutes today. The last thing, which is very important for the business part, is getting data insights and get the insights on all the data your sensors are creating. So what's happened if you have machines, and a lot of enterprise customers have machines and throwing away all the data because they're not using anything. If the machine stops, then a maintenance guy goes and starts the machine again. But nobody checks why it happens and how can we avoid that the next time in the future. And that's why we think that there should be a possibility to collect all the data which are created on the shop floor, and it's called Sitewise. Sitewise is a simple way to connect all the devices via a Sitewise connector or via OPC UA, which is a really familiar protocol for new machines, and sending the data to Sitewise. Sitewise is a part of the IoT, and it is based on a time series database to store all the data from the IoT devices. You can also create some models. You can create a model like a wind turbine, and you can build a model for a wind turbine farm, for example, and make a hierarchy between. So a farm consists of several turbines, and I will show you some example of that. And so it makes very easy to give your operating guys a portal which you have not to design and develop. We're delivering it in a secure manner, and you get a dashboard, and you see all the real-time data of all IoT data. How does it work? We have three different kinds of sources, normally, how IoT data is created. You have devices which sending directly MQTT to the cloud or to any gateway between. You have, for example, the historian database, or an OPC UA device which is sending to a Sitewise gateway to the core and collecting data, or you have some applications which are sending data directly to the Sitewise core. Because Sitewise is storing all the data, and on top on the data you get a portal using that. And I will give you a short view how it could look like. So if you're starting Sitewise, it's already in preview. It's not GA at the moment, but if you have an AWS account, you can go onto Sitewise and create a new demo. I did it in the same way. And what we can do is we can build some models. So we have a turbine model and the farm, which is more or less the grouping of turbines. And one turbine have some measurements as the wind direction, the torque, the wind speed, and this together defines how many power they are creating. And if you define some models, you can assign some assets. And the assets are the real IoT devices, which are matches to the model. And the model is only the abstraction around that, so that you can give them a frame. And if you did all that things which by the way you can automate it, of course, you get a so-called site-wise monitor. And the monitor is a single sign-on portal which can be shared with different customers or different users. For example, each portal is for a different factory building, and the operations of them can see that. Let's jump in and see what we are getting out of that. So that's our single sign-on service, which is reused for that kind of business case. And we have a project dashboard I built, and on the dashboard you can see all the data which coming out from the time series database Sitewise is hosting for you. So it's a full managed service for the portal, for collecting the data. And if you want to use that data again, you can send all the Sitewise data to topics. So you can act on rules and use all the metric data further on for further processing and analytics. Normally it's set to default, but if you check the last day, you can see how the torque is working, and you can also zoom in into that. And that gives maybe the operations manager on site all the important information, how it is working or not. So, and the last thing, we have a lot of data. We have a data in Sitewise, or you have data coming through the MQTT stream, but if you're not storing them, the data are away. So what are you doing? And if you are interested in some historical analytics, or maybe some month later, a manager comes to you and says, I like that data again, or what should you do? So you get a bunch of raw data from all your sensors, and you want to do some really cool analytics on that. And of course, we have a service called IoT Analytics, and it cares all about that. It is collecting the real MQTT messages, all coming in your account, and can collect them. And the whole pipeline for storing them, for enriching the data, maybe cleansing up the data, because you get a lot of bad numbers which you're not interested, or cut out some columns within your attribute JSON files. You can do it on the analytics part. And you can analyze it, can send them further, the aggregated data, and do some machine learning, for example, on it. And of course, at the end, maybe you are interested in visualizing that. How can you do that? That's how the architecture looks like under the hood of IoT Analytics. You have different parts where the source is coming from. So it's things, or it can be S3 data, which already contains some partitioned data on the S3 bucket. You can use Kinesis streams if you have a really fast delivering IoT sensors or some SDK. But all the source data are funneled together in one channel. It's an IoT channel. And that should be IoT sensors which are from the same functionality, for example. And then the analytics automatically stores them. If you don't want to have your own bucket, we deliver a IoT Analytics managed S3 bucket. So it's not stored in your S3 buckets, but managed by IoT Analytics. And you can control all the permissions on that. And store that on S3, which is the data lake, which we're using underneath there. And all the data is stored, maybe structured, maybe unstructured, depends on what IoT sensors you have. And you can build out some portions of that and put them into a data set. And the data set is configured like a SQL query we saw on the filtering on an IoT device. So you can filter only IoT devices which are always on, and then you're interested in the temperature, for example. And the data sets are only the abstraction of the whole data, which columns are available for you, and what attributes and all that stuff. And after that, you can tightly integrate AWS Athena, which is an ad hoc query system, so that you can grab out the data and can visualize it via QuickSight, for example, or you can integrate some other BI tools which are capable to access the data sets. And that means that we are transforming data, and we are gathering data, we are storing data, we are analyzing, processing data, and that's very important, not also for the technical guys running the factories, but also for the guys who want to get some more out of the machines. And that means that IoT can transform also your business outcomes in a positive manner. So, but what happens if the machine stops? If the machine has some problems? You can act on that because the machine maybe sends some MQTT message and says engine stop, but what should you do? So you have to develop your own workflow doing what happens if the event happens. But to make it more simpler for you, we have IoT events. IoT events is like a state machine where you can click together a workflow, and it helps you that you have not to develop maybe a Lambda function and doing all the code which you have programmed, but only use a visual drag and drop tool and click all the states together. And what does the IoT event offer to you? It can detect different models. So you can create a model like we do on the Sitewise, a model for switches, for light switches, a model for IoT buttons, whatever, and you can map the real IoT device to that model. And then you can integrate, of course, with all the services and act on that events. I will come later to that because of times, and we have some more interesting stuff on that. If anybody is interested in that, we can do it afterwards. Another thing which makes it very simple for you to build some stuff like a sequence is IoT graphs. IoT graphs, like the name already shows us, shows relations between different kinds of things. And imagine that you have some models, for example, a light bulb. You can drag and drop all that things together, and I have a sample for here. And that's like a hotel sequence. What happens if a client which was already at the hotel once and have configured his television channel, his temperature and all that stuff, when he opens the door with his card, what should happen? All the IoT devices should run to the default settings of that client. And that's in workflow. So that means if the client enters and opens the door, then the door opener IoT sensor checks in any database, has this client any preferences for that room? If yes, then switch the TV on channel 5, set the temperature to 22 degrees, and also, because it's night, dim the light. That's a workflow. You can develop them on your own, or you can use IoT Things Graph and click them all together. So now we have closed our virtual cycle. And that means the aim of that is that you get an intelligent and a meaningful outcome of all the IoT sensors and devices. And now you should be possible or maybe know the state of everything. So hopefully we can give you all the features to do that. We can give you all the capabilities to get out the data of the IoT devices and also give you all the capabilities to run your business loads. For that was it for the theoretical part. So now I want to switch to my IoT button demo. It's really short to see how that small things works. So for that I have prepared a simple channel, and sometimes it's important not only delivering some data, but it's also interesting to integrate some things in other things. And I use Slack because it's public, doesn't cost anything for me. And when I click on the button, it's a free programmable button. So you can, what happens behind that if I click once again, then hopefully it connects through the IoT core and sends some data into the Slack channel. So that means, okay, I click once, that should signal to all the guys, hey, we need some coffee. And maybe if we click twice, maybe we get another, so we need extra coffee and whatever. And we have a third function, which is a long button. And maybe that should be the signal for after that, and if you do some networking. So let's see if I can click on a long. Because if I click longer than 6 seconds, then we reset the button. So that's very simple, and I will show you for short how the Lambda function looks like, which is acting on that data. And it's really very easy. We already saw the IoT core, where the device is managed. So that's our IoT button. And what we want to do is we would define a rule. If anything comes in, then please send all their stuff, all the attribute data onto that Lambda function. The Lambda function is called IoT button Slack webhook. So let's see how the Lambda function looks like. And it's really easy. And that should show you how easily you can connect things together. I'm not sure if you're aware how Lambda is working, but so I think that's all. Hopefully you can see it. So it's very easy. It's only importing some default modules. And what is very important is the webhook URL, which I defined before and set up in my channel. And I'm getting the event, which contains all the data. We saw it's the voltage, it's the click type, and it's the date. What I'm interested is only what is the event click type. If it's single, then please send it. You need more coffee or send more, and if you do a long, that's it. And send them via response to the Slack channel. And that's the result. So it's very easy to do that and integrate them. That was the single IoT button. The last I would show you is the deep lens. Deep lens is more sophisticated. That's maybe is only a chip, which consists of a Wi-Fi chip and some battery, and that's it. You cannot replace anything. So if it's dead, it's dead. If you have the camera, it's like a microprocessor. So we have RAM, we have GPUs on it, and what we want to do with them is to show how run local machine learning inference and do some image recognition on that machine. So let's switch to that. We have a tool, Deep Lens. So to set the right expectations, that is not production grade hardware. That's hardware which should bring the capability to you developers and play around with all the features, also the IoT button. With some other things like our Deep Racer, which is our reinforcement autonomous car, or we have the Deep Composer to use regenerative chance. It's machine learning stuff. And we have the Deep Lens, which is already registered. It's a Greengrass on the back end, so it's communicating via MQTT and sending messages, but we are not sending the image stream directly to the cloud because we can do the inference locally and see what happens. And I will see if it's working because we're running via that application or that port, yeah. So what you can see is that he can recognize, it's only face recognition, very simple. It's not a well-trained model, but it's fine. So if we are above 25% of confidence rate to detect any face in the audience, then it will gives us the number of the face and do that. And all that inference happens on the device itself, on the GPU. That's very simple. That's a bit longer Lambda function, but the only thing what happens is that the Lambda function we are develop in the cloud and push them back to that devices, to all devices within the Greengrass group, and that's it. That's for that demo, what a Deep Lens can do. And we have a lot of projects running that. By the way, you can buy it for not for free, but you can buy it on the and at the meantime also at Amazon.de, and you can play around with them, and you can push all the sample demos, so we can detect in cats and dogs. We can detect the direction of the head and some other samples, which are very fancy to play with that. And last but not least, I want to give you a smart outlook how a full enterprise reference architecture, when I'm speaking with enterprise customer, could look like. And we called it IIoT, Industrial IoT. And hopefully you'll not be scared, but it uses a lot of services. And we can have a discussion afterwards if you're interested what we are using there, but all of the interesting points I already mentioned are here. So it's here on the factory. So you have different sources. You are using Greengrass, you are using Sitewise, OPC UA, some IoT connectors, sending them back into the cloud via IoT Core, or sending them to IoT Analytics for further processing, using some Kinesis and Lambda functionality, store all the data in the data lake, and afterwards do some BI analytics with Athena and QuickSight. On the other side, you have connected vehicles or some autonomous driving parts. They also use IoT Core, sending them to Lambda and using IoT events and combine them together. And on the other side, we have some legacy software where you need Outposts, which is an Amazon-designed hardware. It's running on your shop floor with Amazon and AWS hardware inside, and send them all back into the cloud. For example, doing some forecasting and prediction of your selling, and using some RDS, EC2, and all that stuff. So that's a real good starting point, discussing what services can do and how they are integrated very tightly into each other. For that, yeah, I'm very thankful that having me here, and for your attention, and thanks a lot for coming. And if you have some ideas, and happy networking.